This is a demonstration video for how we thin section otoliths at the Marquette Fisheries Research Station. We section our otoliths with Buehler Isomet low-speed saws. I'll start by going over some of parts of the saw. In the back there is a master on-off switch, start and stop buttons, a dial for changing speed, indicator lights for when the cut is being made and when the cut is complete. We have the saw arm. You can put various weights on the arm for adjusting how much downforce you want on your cut. There's a counterweight in the back, an on-off switch for when the cut is complete. When the cut is complete, this bolt head will push it down and stop the saw from spinning. A micrometer in the back for adjusting the thickness of your cut if you're using a single blade, or for us when we're using two blades. Adjust the saw arm towards or away from the saw for centering where we want the cut on our sample. The chuck, the blades, some brushes for taking the excess oil and gunk off the blades. And if we spin the saw sideways, there's a pool of coolant / lubricant below the blades, mainly keep the dust off for our purposes. Sometimes when you cut off an otolith, the block falls down in the coolant. So to get that out or to change the coolant, there's a button on the side. You just pull it out and it drops the tray down and you can swing it out. And there's just a little mesh tray in the bottom so you can pick that up. It makes it easier to find your section. One little trick I learned, when you drop this down, there's still oil in the blades and it'll often drip underneath. That's why we have paper towels under here. But if you leave the blade spinning at a low speed, it'll actually keep the oil from dripping down. So usually when I pull this tray out, I'll leave it spin at just a very slow rate. Just so all the oil's not dripping down off the blades. To put it back up, you just swing it back in, slide it up, and push it in. One issue we occasionally have with that is that this no longer wants to slide down. We did some research and found that you actually need to occasionally lubricate the shaft that this rides on. And the stuff that you lubricate it with is stopcock grease. Let's spin this back around. One thing I'll talk a little more about is the saw chuck. This is not the block that came with the saw. The one that came with the saw is made from aluminum, and it has a V-notch in it so that you could either clamp on the flat side or clamp something in the notch. We had an issue with these ones, are actually a couple of issues. The screws or bolts that hold the bottom part of the chuck in place, this block, are stainless steel, and over time they were actually rounding out the holes, making it so there was a lot of slop in it. And the other issue, which was actually the main issue, is that over time the clamping pressure was causing it to bend at the V-notch, which would then stop us from being able to slide it up and down the bolts. Buehler actually does make stainless steel ones, which would probably solve both of those issues, but we decided to make our own based on price. I think the ones from Buehler were something like $75 for just that little block. So our initial fix was to make aluminum blocks that were just thicker, which it solved the issue with the block bending, but over time we still have the problem with the stainless steel bolts rounding out the holes, so you end up with a lot of slop when you clamp down the block, which I'll show you in a minute is an issue for another reason. What we ended up doing to fix both of those issues was getting blocks made that were out of stainless steel. So now the bolts no longer round out the holes and the block no longer bends. But the one problem we still had is with just a little teeny slop in this. When you clamp down a block just on the outer edge, what often happens is the inside of the block will clamp down a little bit more than the outside. And what happens when that occurs is that it angles your block of epoxy with the otolith in it downwards a little bit, which is a problem because you want to cut your section perpendicular to the otolith. They're basically straight across it. So if the block is angling down, you end up with an otolith section that is cut at an angle. And so how I fixed that issue is I drilled out the upper part of the chuck and put in a couple set screws. I adjust the set screws down so they're approximately the thickness of our blocks of epoxy, or maybe just a little teeny bit thinner. And so what happens is when we clamp our block in, this side can't clamp down more than this side, and you end up with a block that's sticking straight out of the saw. Our blades, you can use 1 or 2 blades. We prefer the 2-blade setup just because you can cut twice as fast. You only have to cut once per otolith. And also we end up with sections that are pretty consistent in their thickness. I'll actually show how to take those off. There's just a bolt that holds the whole thing together on the outside. If you spin it slowly, it actually spins the motor, so you can't take it off like that. You actually have to just pop it real quick, and then you can get it to loosen. So bolt comes out. We have a spacer and then a flange. The flanges are smooth on one side and recessed on the other. The recessed side goes towards the blades. The blades usually stick together because they have oil between them. So I just stick in forceps and gently pry them apart. Helps if you take the brushes out. So we have one blade. Our spacers, I couldn't find any material with the appropriate thickness that I wanted. Our otolith sections are about 0.025 inches thick. We end up sanding them when we age, so they end up a little bit thinner than that, but what I found is if I try sectioning them any thinner than the 0.025 inches, they tend to crack more often or break apart more often than if I section them a little bit thicker. So I just found a material from a file folder that was really thin plastic, and it took 2 pieces of it to get the section thickness just where I wanted it. This one, of course, is being uncooperative. There it goes. So the 2 sections of plastic, the other blade, and then another flange. And there are arrows on the blades showing the direction of spin. Let's go finger tight and just give it a quick jerk there, and it's tight enough. Put the brushes back in place. Our otoliths are embedded in blocks of epoxy in these silicone embedded molds. These are Lake Whitefish otoliths. Pop this one out. And to put them in the saw chuck, I just kind of hold it in place and finger tighten. Works out really well where just finger tight will hold the block in place but still allow you to move it around. As I mentioned earlier, you want your section to be perpendicular to the otolith. So you want that otolith to be straight out across the saw blades, and then also you want it not to be angled up or down. So straight across is what you're looking for. Once you have your block angled where you want it, you can then adjust the arm to center the otolith over the blades. You want the nucleus of the otolith to be between the blades because you want that to be in the cut or as close as possible to the cut. Fortunately, you have quite a bit of leeway, or at least a little bit of leeway, with where the nucleus is, so that you only just have to do a rough eyeballing of where the otolith is centered. But you definitely want it to be centered in the widest portion of the otolith. Generally, when you just eyeball it, you end up with a section that's good enough for aging. At this point, you can either adjust the arm in or out or tighten it. I just, personal preference, tighten it first. And this is one of the most important parts. If you forget to tighten these bolts, what can happen is the block of epoxy might shift and bind on the blades and break them, which we've had happen before. Which actually brings up a discussion about the blades. The blades we're using are from Kingsley North. Bueller also sells blades. The price of the Bueller blades is like $322 a piece. That's where we were the last time I bought them, which was several years ago. The Kingsley North blades are, or were a few years ago, $33 a piece. And they perform pretty much just as well. If I had a preference, I would go with the Bueller blades. I think they provide a little smoother cut, and I just like how they behave when they cut the otolith off a little bit better. But for the price difference, the Kingsley North blades are perfectly fine. So to make our cut, we first turn the saw on at a low speed. I usually dial it down to around 2, and we set it down on the blades. At this point, I turn the speed up to 5. I just sort of arbitrarily chose that speed because when the speed is running at 5, the amount of time it takes to cut a section is roughly the amount of time it takes to set up another section on the other saw. That way I'm just going back and forth between the two saws. I'm not waiting for a otolith to be cut before I can move on and set up another one. After a while, you get used to watching how the saw behaves to know when the otolith is almost cut off. What I do when it's getting close to being finished, I turn down the speed, and you'll see why. Hopefully the block will end up where I want it to, and then I'll explain why it's a good thing. So it's just about cut off, and that one worked just the way I want it to. You can tell when it's just about cut off because this little portion will start shimmying up and down, and also you can tell by the sound the pitch of the cut will sort of change, and so just when that sound changes, you know you have like 1 or 2 seconds before the cut is finished. If you don't slow down the speed on the saw, what will normally happen is the blades will do a full revolution before they come to complete stop, and the brushes on the backside will knock the block off, and so you have to go down in the fluid to find it, or sometimes they'll throw it somewhere. So it's always easiest just to slow down the saw, and this will end up right where you want it. So this is what I like. The section is actually still attached to the block just by a little burr, and most of the time, if you're really careful, you can actually just grab onto this block and slowly pull out, and it'll pull the section off with it. If it breaks off, then you can just reach in between the blades with the forceps and pull it out. So let's see if it works this time. It did. So right there is the section still attached to the block, and it just comes right off. We don't need the remaining parts of the block because we've taken out the section with the part we want to age, along with the thickness of the blade on each side. There's really nothing ageable left over. So I throw this section back in my scale envelope, and that one is finished. Do another one. So just go a little in, finger tighten. I look from above to angle the otoliths so I'm perpendicular to the blade. Adjust it so I'm centered over the widest portion of the otolith. Again, very important to tighten it down so that the block doesn't shift and break the blades. This one actually is angled down a little bit, which isn't ideal, but I think it's good enough. And start the blade slow, set it down gently, turn it up to 5. And again, this is where I'd normally be setting up an otolith in the other saw to cut. So that this one was cutting while I'm setting up that one, and I can just jump back and forth between the two saws. When you put the block in the chuck, you also want to make sure that the chuck isn't too close to the blade, so the block has to be sticking out a bit. Because what will happen, I'll slow this down a bit, if the chuck is really close to the blades when it cuts off, this block will actually drop on this flange, and then the saw won't stop spinning. Not as much of an issue if you're using a thinner block on the bottom, but with our thicker blocks, that can be an issue. So just about finished cutting. And there it goes. So it's going a little too fast, so it spun down in the fluid. It may have dropped down, I'm not sure. So what I'll do is I turn the speed all the way down to 0, hit start, and then I'll just up the speed and see if we spin around. And there it is. So it's like the other one. I'll try to gently pull it out. That one popped off, but the section is still there. And there's a little bit of flex in the blades, so you can put the forceps in, grab the section, and pull it out. And we'll do one more. Finger tight. Down from above. This is perpendicular. Center over the widest portion. Make sure it's good and snug. Start at a low speed. Set her down. Oh, put the brushes back in place. The blades are through the otolith and back to epoxy. Now they're almost finished. See, that one, the block landed on the flange, so it kept spinning. Not a huge problem, but I guess it's a good example to show why we want to make sure that the chuck is not too close to the blades. So just stop it with the button. So you just landed on the edge of it. So the block fell down somewhere, and so at this point we have to find it. So all I do is spin, pull out the knob, drop it down, spin the blade slow so that the oil doesn't drip down. Swing it out, pull up the screen. That's the end of a different block that dropped down, and there is our block with the section still attached. Swing it in, up, pushing the button, and I stop the blade. Put the brushes back in their place. And so there is the section still attached to the block. And that is how we section our otoliths.